Computers are all around us. We use them so much that it's impossible to imagine life without them. That's why computer companies are making better computers to meet up with modern demand. Sadly, computer progress is slowing down because it's getting tougher to fit in more processing into lesser spaces. And one day, this progress could even stagnate. So how do we solve this problem? Introducing neuromorphic computing, which are computer chips based off of our own brain. So let's start with the human brain. Our brain has 100 billion neurons, which form 10 trillion connections with other neurons at junctions called synapses. It is due to this level of connectivity that allows for more communication and processing speed in our brain. If we zoom into one neuron, we see dendrites, a soma, and an axon. If we zoom in even further, we see that the surface is covered by thousands of ion gates. When a dendrite receives a strong pulse, these ion gates open and allow the inflow of ions like sodium into the neuron that causes an action potential, allowing the neuron to carry the information. However, if the pulse is weak, the ion gates don't open. The pulse is stopped, hence the neurons would have inhibited the pulse. This kind of resembles the binary 1 and 0, and this is also how large systems of neurons can communicate and relay information. If we look at computers, zoom into any computing device far enough and we'll find a device known as a transistor. Depending upon the input received by the transistor, it can either allow the flow of electrons or deny it, representing the bits 1 and 0. Kind of like our neurons, right? Standard computers today use a system called von Neumann architecture, in which an input received would go to the CPU, which simultaneously brings data from the memory unit to execute tasks. Notice how the memory unit and CPU are separate? This separation not only creates a lag in processing, but also bottlenecks information because of the constant shuttling of it. This is where neuromorphic computing makes the best of both worlds by using a complex structure of densely integrated transistors to improve connectivity and speed up processing. In neuromorphic computing, common inputs called dendrites send their information into something called a synaptic plasticity array, which is interconnected to a soma. Due to the close proximity of the SPA and soma, this bottleneck is prevented and the processing speed improves. If this structure makes one neuron, then a neuromorphic chip is made out of thousands of these neurons, all communicating with each other, ultimately leading to faster processing, lesser energy consumption, and the ability to process and adapt to sensory data, which ultimately makes neuromorphic computers better than standard computers.
Huge uppercut by Adam!
This technology has thousands of applications, ranging from heavy-duty simulations to self-driving cars to artificial intelligence. With all these changes coming, get ready for a whole new meaning to the term brain power.